right, it is 2 o'clock. Welcome to everybody who is still coming into the class. This is the Conditions for Termination, Site Stabilization, and Final Coverage workshop. Welcome to Stormwater Awareness Week. Matt, if you'd like to introduce yourself and we can get started.
All right. Hey there, everyone. My name is Matt Lewis. I'm a QSP here at WGR. And like Gabby said, we will be talking about site stabilization, final coverage, conditions of termination, or what is commonly known as achieving an NOT, Notice of Termination. So it's pretty straightforward, but there is some cause for confusion that hopefully I will dispel today. So let's see here. All right, so bear with me while I read through a little bit of this. This is found in the 2009 order. I use a 2009 because probably most of our sites are still under the 2009, but soon enough we'll all be under the 22 CGP, and it's more or less the exact same. So conditions for termination of coverage. Within 90 days of when construction is complete or ownership has been transferred, the discharger shall electronically file a notice of termination, an NOT, a final site map, and photos through the state water board SMARTS system. Filing an NOT certifies that all general permit requirements have been met. The regional board will consider a construction site complete only when all portions of the site have been transferred to a new owner or all of the following conditions have been met. So there are a number of conditions here. I'm going to bounce around a little bit, but I'll just read through them quickly. Condition A, for purposes of final stabilization, the site will not pose any additional sediment discharge risk than it did prior to the commencement of construction activity. This is a condition that I will probably expound upon in the greatest detail. But just to move on real quick, condition B, there is no potential for construction-related stormwater pollutants to be just discharged into site runoff. C, final stabilization has been reached. I'll touch on that last. D is construction materials and waste have been disposed of properly. E, compliance with the post-construction standards in section 13 of this permit have been demonstrated. F, post-construction stormwater management measures have been installed and a long-term maintenance plan has been established. This is probably where most of the confusion comes in right here with post-construction. And G, all construction-related equipment, materials, and any temporary BMPs no longer needed are removed from the site. So that is probably the number one reason why NOTs get denied, is because BMPs, temporary BMPs, are left on site. For instance, rock bags are left in the gutters. There'll be a porta potty or a trash bin, something of that nature, but there will be in the site photos that are required up in one up there that the discharger shall electronically file a notice of termination, a final site map, and photos. So photos are what always gets you, and usually it's temporary BMPs still left on site that will get you denied an NOT. And like I said, the most common are rock bags, porta potties, and trash cans. There can be fiber roll and things like that left, but it's usually, probably more often than not, the porta potty and the trash bin that is preventing you from getting an NOT, because they want to see that all construction related activity is done. And if there is a porta potty or a trash bin, they just assume that that is not the case. So I'm going to move on to post-construction. Now, I'm going to try not to get into the weeds too much because this is a topic that can just totally derail this whole conversation into one specific area, but I'm going to just highlight or point to the highlighted section down there at 3. The discharger shall, through the use of non-structural and structural measures as described in Appendix 2, replicate the pre-project water balance. So let me just go back real quick. And condition A, for purposes of final stabilization, the site will not pose any additional sediment discharge risk than it did prior to the commencement of construction activity. So in short, your site cannot have a discharge risk or risk of discharge that exceeds the pre-construction environment. So this is pretty straightforward. Most sites tend to be something along the lines of a vegetated field, and that field is more often than not surrounded by a curb cutback. So the potential for discharge is usually pretty minimal, and the erosion controls are usually natural and are in place and are doing their thing. And so what the water board wants to see is that when the site is now developed, i.e. the site has become impervious, it is no longer allowing water to soak into the soil. It is discharging, for instance, I can think of a site that built a hotel recently. It was a big grass vegetated field, and now it's a big impervious parking lot, and it will be discharging all sorts of materials, oils, sheens, different metal particulates that might come off the roof, just the whole variety. It's pretty straightforward, common sense that a vegetated field is going to be producing a lot less contaminants than a developed site. So if I can move on here. So that usually has to do with something that is known as an LID, or a low impact development. When we go back down here into 3, it talks about non-structural and structural measures that will replicate the pre-project water balance. So low impact development, again, this is a topic that can totally encompass many, many hours. I took this off of the Public Works Los Angeles County website. The actual document for low impact development is almost 500 pages long, so it is an extensive topic. But usually what will help you achieve that pre-balance result is what is known as low impact development. Now, if I can just move this little thing so I can read this fully. So a low impact development, or commonly known as an LID, is a design strategy using naturalistic on-site BMPs to lessen the impacts of development on stormwater quality and quantity. The goal of LIDs are to mimic the undeveloped runoff conditions of the developed site with the post-development conditions. So let me read that again. The goal of LIDs is to mimic the undeveloped runoff conditions of the developed site with post-development conditions. So again, the idea is that they want the post-development conditions of the developed site to mimic the undeveloped or pre-conditions of the site. So I know that's probably a bit confusing, but this is usually down here in this table. There are many, many others. Oops, I'm sorry about that. Got it out of control on it. There we go. Let me try to move this thing again. So these are generally, and these will be decided upon in the design phase. Engineers, what have you, will choose these. But the most common ones, there are many, but I tried to pick the table with the most common, are stormwater planters, tree well filters, basins, extended detention basins, and my personal favorite LID is a permeable pavement with an underdrain. So what all these are meant to do is to capture the stormwater that is leaving your developed site, filter it in such a way that it produces what we like to call the R factor, which is your erosivity, the number. It produces that same number. So let me bounce over so you might have an idea of what this looks like. I just pulled up a SWIP that John had done for one of our clients. So bear with me. This is definitely getting into the weeds, but I'm just trying to give you some background of what you're going to be actually looking at. So you can see the start date here of a site, 7/15/24, and it ends 4/30/26. So what John has done is he's basically taken the R factor, which you can find on the state water board right here. You have to have two things. You'll be looking for a high receiving water risk, and then you will be going down to a sediment risk, which is the combination of your R factor, your K, and your LS, which is your R factor is your erosivity, how much a site has the potential for runoff during an annual year, the erodibility, the soil type, and its erodibility factor, and the length and the steepness of a slope. So you usually use these three. There are two other, a cover and a practice, but you usually use these three to obtain what your R factor will be, or how many tons per acre per year will be coming off your site. So as you can see right here, it's 118 tons will be coming off this site within 2 years, which is rather high. But for each year, it's roughly around 43. So when it gets back to that preconditions of your site, say if we were doing this site here, which is in Pittsburgh, and it's on a hillside, so that's why you have a rather high sediment yield and also receiving water risk. This is what you would be looking for. So do your post-development conditions achieve an R factor annually of 43.02 tons per acre per year or less? So that's how you sort of understand what your goal is at the end of development, trying to get your R factor, your erosivity factor down to this level. So if your calculations post development are not getting you these levels, then you've got a lot of trouble on your hands. You're not going to be able to achieve a notice of termination. And that's where low impact development really comes into play, where designers are going to want to really keep that in mind, because it's only obvious. I mean, this is 43.02 tons per acre per year on a totally vegetated site. So imagine now, if I'm not mistaken, that will be a bunch, it's like basically a subdivision that will be built on this hillside. So it's, if there's no low impact development, if there's no planters, if there's no retention basin, if there's no really post BMPs in place at all, you're definitely going to be above this number here, and you're going to have some issues, and you're going to be ripping up your site trying to install, let's see, where were we down here, tree well filters, stormwater planters, all different types of things like that. So I know this is getting into the weeds, and it's making it probably a lot more confusing than it needs to be, but that's kind of where you're at there when it comes to, let's back up here, the dischargers shall, through the use of non-structural and structural measures, replicate the pre-project water balance. Okay, so bear with me. Hopefully this is something that, let me try to get this thing out of the way. Sorry, Zoom is the bane of my existence. Okay. Sorry. Jeez Louise. Okay. So we've touched on post-construction quite a bit. And of course, I'm sure you'll probably have some questions about this, but let me just move on so this isn't just painfully long. So the other one that I want to focus on before I go to final stabilization, which is by far the easiest way to achieve an NOT, is condition D and condition G. So these kind of work together. Construction materials and waste have been disposed of properly, and all construction related equipment, materials, and any temporary BMPs no longer are needed and removed from the site. So D, hopefully there's no construction material or waste impacting your site because it's done and completed. Hopefully it's landscaped properly and everything is cleaned up. But really, if I were to give an example of what that might be, it's probably because now, as I'm sure most of you know, in say subdivisions, for instance, most backyards are not landscaped. Usually now it's only the front yards that are landscaped. And what happens so often in both the front and backyard is that, say, concrete guys, stucco, painters, tilers with their thin sets and whatnot, they will like to wash out their equipment, their tools, and right into the backyard. They'll throw a nice huge bucket full of waste materials in the backyard, and they won't dispose of it properly, say in a concrete washout bin or something of that nature. So when you're trying to take final NOT pictures, and say what I do, I shoot a lot of photos with a drone now. And so I'm flying over a house and the front yard looks beautiful. The streets, everything are totally done. And then all of a sudden you see a big, huge concrete washout or something, stucco, paint, what have you, a big white mess, spread throughout the backyard. That's going to get you a denial. Now, a lot of these yards are at least mulched, but not always. Sometimes they'll put like a sort of weed abatement down, and I've seen it where guys throw their maybe some painters were coming in late, and they'll wash out their buckets or whatnot right onto the weed abatement. And so it'll be plain as day. You'll have a black weed abatement, and on top of that there'll be some white-ish washout thrown all onto it. So that'll get you dinged. But then, like I said, to start, all construction related materials and any temporary BMPs are no longer on site. So again, the main ones are rock bags, porta potties, and trash bins. Now, of course, you can have silt fences and compost sock and fiber roll and all that sort of stuff. Equipment, for instance, just, a big, huge forklift or a backhoe, something, rock truck, anything. All those sorts of things can get you denied. Even if you have a fully completed site, it can get you denied. Now, sometimes the site will be completed, and I'm sure many of you know what happens when a homeowner comes in to a newly completed home. They start tearing up the landscaping right away, or they start putting in a swimming pool or what have you, building a retention wall for something. So if in those sorts of circumstances, I always put in my notice of termination application, I will attach, or a lot of the times I put it right in the actual photo document itself. I'll create something like a Word document that has boxes, explanation boxes next to each photo, because they usually want to know the direction, the location of the photo itself. And so usually I will put it in there, or maybe in a separate Word doc or something like that. I will point out that this porta potty or trash bin or whatever is actually has been brought in from the new owner. And I've never, that I can recall, had to prove that, but that's something that you should always put into your document. And because people at the regional water board, they understand that that's what happens, but you just want to make sure that you document it, because they will think that construction is still active if they see a porta potty and a trash bin or something like that on site. So let me see here. So we've touched on all this. Okay, so sorry, let me go back real quick and point out condition C again one more time. Final stabilization has been reached. Okay. Now you would think this would be straightforward, but it is sometimes not. So let me just read through this real quick. The discharger shall certify that final stabilization conditions are satisfied in their NOT. Failure to certify shall result in continuation of permit coverage and annual billing. So this is why it is so important to achieve these NOTs, because LRP and the owner will be continued to be billed even if the project is done and they've moved on. The NOT must demonstrate through photos Russell, which is a revised universal soil loss equation, which was getting into what I was pointing out in that SWIP with the R factor, the K factor, the LS factor, and whatnot. Or results of testing and analysis that the site meets all the conditions above, and the final stabilization conditions are attained by one of the following methods. Okay, so A is what we're going to focus on here, because this is generally how most people will achieve an NOT, is through final 70% coverage. No computational proof is required. You don't need to deal with the Russell 2, or any custom method of computation. So 70% final cover method. Now, a lot of people will think this means, say you have a field that 70% of the field is stabilized, whereas the other 30% of the field is not stabilized in any form or fashion. This is not the case. What they mean by 70% final cover method is that 100% of the field is stabilized, but that it has achieved 70% of its total growth potential. So this is open to interpretation, to say the least, because what does that mean? What does a grassy field, where is a grassy field 100% grown in versus 70% grown in? So I'll just show you a few examples of when I am out to trying to take a NOT, trying to document an NOT. This is generally what I see. I'll have my contractor say, "Hey, Matt, I've got vegetation. I want to shoot some NOT photos." Be like, "Okay, perfect, great." So I go out on site, and usually this is what I see. I see little bits of grass popping up, or if you'll see here on the left, it's a little more fuller than this one on the right, but it's still in the early stages of development. I'll bounce over. This is also what I see very often. This is the site that, went inactive for some time. They were thinking about NOTing it because they didn't want to keep paying annual fees and all that sort of stuff and paying for me to go out there every month to inspect it. And I told them, look, there's just no way. There's no way. This is after the rainy season here on the left. And you can see that there is plenty of space where it has not achieved even close to 70%. I mean, some of this is zero. Now, what I have here on the right is something that I had during the summer, and then during the winter, which will be this last photo, you can see, right? That's 100% more or less. Even though you have these little spots down here at the bottom, the waterboard is going to give you a break about that more often than not. Because when I bounce back, right, this is what we had before on the right. So that's just barely coming in, some of it left over from last year versus this. I mean, this is 70% and above full vegetated growth achieved here. Now, just to wrap up, because I'm going to give you guys time for questions. If you thought that this presentation was about as exciting as watching grass grow, guess what? I actually am going to make you watch grass grow. So I found this time lapse. It's about 2 minutes long, and it will sort of illustrate what I am usually called out to go shoot, where 70% vegetation is roughly at, and then full growth. So bear with me. And one of the things that I do see when it comes to vegetation or the achieved, so let me just stop it here at 9 days once it comes. So this is roughly what people call me out to see. And if you have noticed, there's a sprinkler here. What a lot of people don't do is they don't feel the need to water their newly sodded field, which is usually, they don't ever seed a field usually, but sometimes, it happens. But this is about where I'm called out to shoot an NOT, and it looks pretty good. And if you shoot it at just the right angle, you might get an NOT. But this is only probably, I would say, about 30%. So let me just move on. So as you can see that it's going to take about 2 weeks for vegetation to be grown in. This is probably right around 50%. And I would say it right about 2 weeks is pretty close to 70% vegetation. Now, as we're working through this, I'll just mention that when it comes to contractors hydro seeding, you want to make sure that you give yourself enough time prior to a storm event for the tackifying element within the hydro seed to set. So the worst thing that you could probably do is bring out a hydro seeder the day or two before a storm event comes in. So right here, just to stop myself real quick, this is about 70%, I would say. This is good to go. But what I was saying when it comes to hydro seeding, you want to make sure that you give your hydro seed enough time to tackify so it doesn't get washed away in your next upcoming storm. This happens more than you would believe. Contractors often don't want to wait, or they often don't want to have multiple applications of the hydro seeder. They don't want them to come out one day and then 2 weeks later. They don't want it to follow the stage of development. They just want them to come out one time, and usually it's at the last possible minute, and they want them to hydro seed the entire place. And a lot of times this costs them not only headache but a serious hit to their pocketbook because their hydro seed just gets washed away because it didn't have time to tackify. So as you can see, this is a beautifully grown in lawn at roughly 100%, I would say. This is right, maybe 5-10%. This is when I usually get called out. Not quite there. Some regional inspectors or a water board people are not going to certify your NOT. And then at roughly 2 weeks is when you're probably going to be able to achieve an NOT. So just keep that in mind, that you're probably going to need 2 weeks if you're starting from seed like this. Now, of course, a lot of people just have sod imported in, and so your lawn is all looking proper right from the get-go. But if you have surrounding field that is not vegetated, say, getting back to the example of my my hotel, they have a big field next to them that they had exposed for some time, and they weren't able to get vegetation. And so what did they do? They ended up rocking the entire remaining portion of the field and using it as like an overflow parking lot. So of course you don't have to have grass grown for vegetation. You can have it rocked, you can have it mulched, straw. There's different things that you can do to achieve stabilization, but you're just going to need to point that out in the design phase, so the water board knows that this is what you're doing. Or you might have to do a change of information to adjust for that inability to get vegetation to grow. So with that, I think I've rambled on long enough, almost a half hour. I'll open it up to any questions if you have any. If not, I will post here let's see, get this thing out of the way. Let's see. Of course I can't. There we go. Are you gonna let me do it? Yeah, sorry, Zoom killing me here. Here is my email address coming up somewhere. You can email me anything you want, and I will be sure to get you the appropriate answer. So with that, I thank you for bearing with me. You know, this was about as exciting as watching grass grow. That's why I figured I would torture you with that at the end. So if there's any questions,
You
shoot them at me.
you do have a couple of questions.
Okay.
One from Steven. What
Mm-hmm.
if hydroseeding was used? Is there a need to wait for 70% growth to acquire an NOT?
I'm assuming in the question that now a lot of times hydro seeding, we always call it hydro seeding, but often the seed element is left out of the mixture. So it would just be a hydro spray, you might call it. So if I would say that if that's what you had originally designed, that you were just going to spray and stabilize with a tackified mulch, something of that nature. Perhaps even if you're really going to be on top of it, you'd lay down an erosion control blanket and then spray a tackifying mulch on top of it. Yes, you'd probably get an NOT certified. Um, it's just something that, again, it's not always the case, but if you can anticipate that in your design from the beginning, that that's how you're going to stabilize, then you should be good to go there. Especially if, say, your project finishes in the summertime, you know, and it might be unfeasible for you to water an entire field, what have you. Um, yeah, you'll probably be okay. As long as it's stabilized, uh, you're probably going to be okay.
Okay, I have another question here from Jeremy. Does the term water balance infer post-construction water quantity and water quality? Does the permit allow for application of non-vegetative stabilization such as wood mulch on on all disturbed areas to meet the final stabilization requirement?
Yeah, as long as you're stabilized, you know, you have some sort of erosion control. Now, again, getting back to for purposes of final stabilization, the site will not pose any additional sediment discharge risk than it did prior to the commencement of construction activity. So if you can show that your R factor, let's bounce over to that again real quick so you can just see what this will probably look like in a SWIP. I'm sorry, you guys are probably seeing this stupid bar in the way. So if you can achieve this, if you can get, say your site was discharging annually 43.02 tons annually prior to development, if you can show through, as it said, let me bounce over to the final stabilization. Here we go. Either 70% final coverage, no computational proof, or through Russell. So this is Russell here. Russell is the revised universal soil loss equation, which is R times K times LS, and there's usually times C times P, which is cover and practice. But often all you really need is these three factors because C and P are one. Um, so if you can show through Russell that your site is not going to pose an erosivity factor higher than your pre-construction activity, then you will be able to achieve an NOT. Now, how do you exactly do that? You really have to know your Russell equation, because when you would get into let's see if I scroll down here, if I can get into, it'll be too much to look for, but your cover would be mulch, for instance, has a certain value that you would times onto this equation. So any sort of cover is going to drop down, usually, not always, but usually, it will drop down your overall R factor. So if you can show R, which is the erosivity of the site in its normal state, which here would be 43, then you have your K factor, which for this site, that's the erodibility, the type of soil that you have, and the potential of its erosion, which here for this site is 0.24, and then your length and your steepness of your slope or your site, which is 5.8. So all this times would be 118 tons. Now, a lot of times the cover factor can lower this. So that's just something that you sort of have to play with, is your Russell equation, to determine that if just laying down mulch will achieve the desired result for your overall, or technically your overall A factor, your annual soil loss per tons per acre per year. So that's just something that you kind of have to play with. But generally, if you are employing erosion controls, a cover, then you're probably going to be successful in achieving an NOT. But that's just kind of something you got to play with a little bit. And if you want, I can just send me an email. Hey, Matt, can you, send me some screenshots or give me a link to the Russell equation? And it's pretty straightforward. I can show you all the different types of cover numbers and values. That it's just in a nice little chart. It's very easy to follow, and you just pick one of, I don't know, 10 or so different cover practices, and that'll help you with your equation.
Okay, and then you have another one from Amelia. Can you talk about the pros, cons, and pitfalls of straw applications?
Well, straw is not a bad option. For instance, if any of you have ever been to John Taraskis, our QSD, if you've ever been to any of his QSP, QSD classes, he likes to talk about straw wattle and how most people don't understand that fiber roll, straw wattle, is not a filtering agent. It is a repellent of water, and he likes to point out that in some underdeveloped countries, still you will find straw thatched roofs, and it's because straw prevents water from seeping through, especially if it's thick enough. So if you have tackified straw, it's a very good erosion control. It's a very good cover to put down. Now, if you're just sprinkling it by hand, which, believe it or not, is very often the case, you're going to have some issues there for sure. Now, if you can sprinkle it down and maybe get some compaction on it, you might have more success. Now, will the water board be fine with that? It's kind of a crapshoot. Some of them, it just depends on the person, really. As crazy as that is, probably I would say you've got a pretty good chance of achieving an NOT if you're just laying down straw by hand. Is it the best way to go about it? Probably not, without a tackifying agent. would the regional water board ask you if there's a tackifying agent there? Like, say, if they notice that the straw is laid down on a hillside, uh, I wouldn't be surprised at all if they were to inquire about that. And if there is no tackifying agent, that you would get denied, perhaps. Uh, but if it's on a nice, level, flat plane, then that might be totally acceptable. It might be acceptable for sure. So, there's definitely better ways to go about it. But if that's all you got, say if you're, you know, if your budget's a little tight at the end of a project, you know, go for it. You never know what'll happen, really. I mean, some of these NOTs, it really is that. It's kind of a coin toss. If, when you start to try to improvise, if you will, on these covering practices, these stabilization practices. But you might get lucky, and then again, they might push back and say, I don't know. It just depends again on your site and the steepness of your site.
Okay, and then I believe you may have touched on this one with the past two questions. If you use rock, mulch, or straw, doesn't it have to be 100% covered?
Yes, for sure. Yep, everything has to be 100% covered. No matter what type of cover practice that you're using, it's got to be 100% of that site that is still yet to be developed has to be stabilized. So, if you've got planter beds, for instance, planter beds, let's see, I have a site right now that is completed. It's basically was a roadway project, but they have a rather large median in the middle of the road that is going to be, I believe they're going to put trees down it. They'll probably mulch it, put trees and sort of drought resistant vegetation throughout it. And I had the contractor ask me, or the superintendent asked me, can we get an NOT out of this? And I informed him more than likely not, because the median is still exposed. It has exposed soil that is not stabilized. Now, if you stabilized it, again, getting back, maybe you put some straw down, maybe you mulch it, maybe you rock it. Yeah, there's a chance that you could probably get an NOT out of it. But yeah, whatever is within the footprint of development, in the end, all of it has to be stabilized. The tiniest little flower bed can get you denied. You can have your entire site totally stabilized, and a tiny little flower bed can get you denied. Um, you know, it's just the way it is. It's not always the case. Sometimes they'll give you a little leeway, but more often than not, you should always plan on 100% site stabilization in the end.
Awesome. And then are NOTs held up by the water board if vegetation is not established in post-construction BMPs like bioretention, swales, etc.?
Yeah, I mean, if you have a lot of municipalities are more and more requiring post construction BMPs. And if you have them in your plans that you're going to be installing them and they're not installed, obviously you're not going to get, because the water board is going to be privy to that. So you're going to get denied. But yeah, I'm sorry, what was the first part of it about vegetation?
Are
The first part
are
of my question.
NOTs held up by the board if vegetation is not established?
Yeah, definitely. Yeah, you've got to achieve that 70% of total growth. Um, Now, again, when I was showing you that video right at like 50% vegetation, if you shoot it at the right angle and it looks more full, you'll probably get away with it. But yeah, the water board's pretty hip to that. They look at these things all the time. So you're not really going to ever pull a fast one over them. So yeah, you're just going to need to wait till you get 70% of that growth. It's going to be, you know, kind of a discretionary thing. You're going to just have to do your best guesstimate if you think that this is about 70% of growth. And once you get there, yeah, you shoot it and say if you're at like 50% and you try to submit it and you get denied, really the only thing that's going to happen is that the water board's going to be like, hey, I don't think you've achieved this. Send me some photos. They probably won't say exactly, but really it's like send me some photos in a couple weeks, kind of thing. And it just needs to achieve that vegetation a little more in its fullness. And then you'll get it. And it's a little bit of a pain in the butt because potentially have to go out and shoot some more photos, update your Word document or your PDF or whatever it is that you've sent them. But it's not the end of the world. But that's probably what will happen.
Okay, and then I have another question for you from Richard. For
Mm-hmm.
what applications would you use the custom method for final stabilization? And how often do you see it used, if at all?
That is a fantastic question that you email me. I have personally never seen it used, the custom method. Um, so, just off the top of my head, Richard, if that's right, I don't know what a I've never seen it. I've been doing this for about 7 years now, and I've never seen, and I've done, geez, probably over 100, if not more, NOTs in my time here at WGR. And I've never seen the custom method used. And what I would think that would entail is if Russell isn't getting you your results and you don't have the ability to have vegetation. I mean, I'm just trying to think of something that would be, I'm sure that John could probably, in his storied career, could think of a time when he's had to use a custom method, but I know it is very rarely used. I've never seen it. Um, but I would just assume that if your Russell isn't getting you your numbers, you don't have the ability for final stabilization through vegetation, and you know, yeah, you would just have to come up with something, maybe a combination of low impact development. Um, but if you want, Richard, just send me an email. Hey, I was asking about the custom method, and I can try to dig up some examples of when people have used the custom method. Because I mean, shoot, I wouldn't mind knowing myself, but I've never seen it done. I've never had to do it. And I do know it's a pretty rare circumstance from what I have heard that people need to use that custom method.
Okay, then I think this is our last question for now. Have you seen success with NOTs when contractors use gravel base or aggregate base as a form of gravel cover?
Sure. Yeah, totally. Like for instance, that the example I used of that hotel, they had, they graveled uh, that portion of their site that they were using as basically their staging area, and they had turned it into just a muddy, stinking mess, and they had destroyed all their natural organics. And
real motion or pretend motion anymore because half the time I don't see anything.
and yeah, so yeah, gravel stabilization definitely works. And again, it's something that you would try to put into your design at the beginning so the water board could see that this is what you intended. But yeah, that's a perfectly acceptable stabilization method.
It looks like I have another question for you, Matt, from Mel that just came through. Any examples of site maps for NOTs?
Let's see. Let me see real quick. Let me pull one up. I can pull because I have a let me see if I can get rid of this. Okay, so this is usually what an NOT looks like for me. So I have the site here, the name, location, the date and time. John is the primary data entry person here for WGR, and the WDID number, the waste discharge identification. Usually what I start off with is the original map that comes directly out of the SWIP. Let's see if I can zoom in a little bit here. So this is what I usually have. And then going down, this is kind of the gist of it. So I just go through the whole site, and you can see the site is still active. This is, we did a change of ownership. So in the NOT, if you do a change of ownership, it's kind of nice doing a change of ownership. You don't have to have the site totally stabilized, but you sort of have to go through the NOT process. So this is maybe not the greatest example, but just imagine that all of this site is stabilized, but this is just the sort of layout that I use. So I just, right, have the photo, then I have a description. They want to know where you are taking it and what direction. And then I just walk the site, take pictures. And as you can see, this is a very short one. Let me try to see if I can find one that is actually completed. Oh, wait, this is a COI. Let's see. Okay, so here's it's not in the actual form, but as you can see, let me just bring these up real quick. So they've got it mulched. Now, this was something that I actually had to wait. As you can see, there's all this dirt here where the trees are. I actually had to wait. I tried to submit this, and they said, no, this is not acceptable. You got to wait for vegetation to come in through there. So I actually had to wait for vegetation to grow. This was all laid down sod. So, of course, it looks beautiful right from the get go. But I shot all the photos, right? And so this is kind of, so as you can see, you've got your mulch, you've got your natural vegetation as the grass, but you had a huge section, right? This big dirt section here in the middle that they were trying to grow natural grass in for whatever reason. I don't know why they didn't just lay it down. Maybe there was a budgeting issue. They didn't want to add that much extra. So that's something. And now what I usually do is after, so this is what I do. Now I do it, I'm a little rudimentary with the way that I do the final map. So I create the map, or I create the photo, the documents, I add the photos, I put the map, and then I come in here and just jot down where, see, these are pictures 1 and 2 were shot from this angle, 3 and 4 were shot from this angle, 5 and 6 and 14, 7. So you can get obviously a lot more technical and just create, in like a Photoshop or something like that. You can, make it this a little bit more official. I have found that it doesn't need to be that fancy. You can literally just go in with a pen or a pencil. I always use a pencil because I inevitably make mistakes. So I can erase if I need to. But this is usually what the end result of the map looks like. In that previous one, that was prior to me marking up the map. But usually the first photo is this map here that is taken from the SWIP, which is really handy. That's what the water board usually likes to see. Then I just do, it's really, keep it simple kind of thing. And I just document where all the pictures are taken, and that's about it. It's I'm trying to see if I can find. Yeah, these are all just the so I could just show you a few of these of what this site looked like stabilized. So you can see this is mulched and vegetate with like natural drought resistant vegetation planted. And these guys got, this is in the Bay Area. these guys got their NOT right away. You know, the entire site is fully stabilized, you know, all around the perimeter. Obviously, the roadway is stabilized. And so, yeah, this is just what it looked like. These are just all my photos. I probably didn't use every single one of these. Some of them are repeats. And then as you can see here, I did the same thing. So I added where I was, let's see, where I was standing, right? Just sort of pointing it out. And this is very rudimentary, but this is perfectly acceptable for the water board. And at least as of now, you know, until they get a little bit more particular, this is all it really takes. So I just took again, I found the SWIP. Usually I go on to smarts, which we got a few minutes real quick. I can show you that. So if you were to go on to smarts real quick, let me move this out of the way so I can see what I'm doing. Go on to smarts, log in. Of course, you're going to have to create a user ID if you don't already have one. You would come into, let's see here, we could go to active applications, which is all the WDID, the active sites. See if we can load this real quick. I got a few minutes. Hopefully I can make this happen. Okay, so here we can just pick, let me see if I can find one of ours. Here's one of ours real quick. So you would come in here to the attachment section. You would come down here, find the SWIP. You can do the whole SWIP, or usually John, he's epic. He has a whole separate section attachment of just the facility site map pictures. I come over to here. Bam. So here's the overalls. And then here's one right here. So right there, I would take a screenshot of that right there. Bam. And that's what I would use for my NOT. Now there's probably a couple more. That one you don't really need. So it would probably pretty much be this one, maybe this one if this is housing pad. Yeah, so it'd probably just pretty much be this one. But that's kind of how I do it. I go into smarts, find my site, go into the attachments, find the SWIP or the SWIP map photos, screenshot that, and then just upload it as a JPEG into a Word document. Go to the site physically, take pictures around the site, then get back in my map. Usually what I do is I'll just print this out, jot down where I took the photos. I'll usually either scan it or just take a picture with my phone and re-upload it onto the Word document. I turn it into a PDF. And then if you're on Smarts, you'd be over here, NOTs. And this is where you would do it. Add new NOT, you'd get into here, and I won't start messing with that. But that's essentially where you do it. And it's really straightforward. Again, if you need any help with any of these sorts of things, just shoot me an email. I'd be glad to walk you through it. No problem at all. So, yeah.
All right, awesome. Thank you, Matt, for a phenomenal presentation. That was super educational, so thank you. Thank you, everybody else, for coming out and joining us for Stormwater Awareness Week. If you missed any part of this workshop or would like to view it later, a recorded version will be available within the next 24 to 48 hours on stormwaterawareness.org. So thank you again for coming out, and we still have 2 more days full of amazing workshops for you as well. So thank you.
Thank you.